Hello, my lovely viewers and my dear students. Welcome to my mathematics channel, Mathematics Made Easy. In today's distance learning class, we are going to be doing a very important topic in continuation with our video lessons for grade 11 and 12. And this is the unit which is differentiation, where we are taking up different kinds of function. So the lesson that we are going to be covering today is differentiating inverse function, and we begin with part 1 of this lesson today. So welcome and let's get started. So in today's session, we are going to be starting with the understanding of the inverse functions. How do we define them? And we'll take some examples. So moving on, let me acquaint yourselves with the learning objectives of today's session. So in this session, you are going to recall the definition of an inverse function, and then you will be able to find the inverse of a given one-to-one function. Okay, so let me first introduce the concept by giving you an example for inverse functions. So here I have taken two sets, set A and set B, and as you can clearly see that the set A has 4 elements and similarly set B has 4 elements. And if I'm defining a one-to-one function f with the domain as A and the range as B, so that means this is my domain, or you can say in simple words it is my input for the function, and set B is my output or my range. This is how we are defining, and remember you can define an inverse function only for a function which is one-to-one. And what does that mean? Let me make you recall what is a one-to-one function. So each element of a set A, if it is mapped to one element, exactly one element of the set B. So like I will show you how I'm defining this function. So I'm defining it in this way. You can look at the arrows and very easily observe that my function f, which is defined from A to B, it is defined in such a way that f of 2, the point 2 in the domain, is mapping to the point 1 in the range. So f of 2 is going to be 1, f of 3 is going to be 7, f of 5 is going to be 3, and lastly f of 9 is going to be 0. So this is the way I'm defining this one-to-one function with the domain A and the range B. So you can write this function in the form of ordered pairs also. So in the form of ordered pair, this function can be written in this form. I will just highlight it here for you. Okay, yes. So the function can also be written in the form of ordered pairs of the form a comma b as 2 comma 1, 3 comma 7, 5 comma 3 and 9 comma 0. Now this is the given function and we know that it is one-to-one. So let's define now the inverse. And I can again show you by the example of the same sets that we have taken for f. So what will happen, this function f inverse is going to be defined from B to A. So as you can observe, the domain and the range are interchanged, and accordingly if we talk about the ordered pair, so for the inverse ordered pair we are interchanging the x and y coordinates. So now the new coordinates become 1 comma 2, 7 comma 3, 3 comma 5 and 0 comma 9. So this was a quick introduction, or in fact a recall from your previous classes for inverse function. So now that you have the concept, let's get on further and get to know more about these functions. Okay, so now we come upon the definition of an inverse function. So let me define it for you now. So a function g is the inverse function of the function f when f composition gx or f of g is equal to x for each x in the domain. So this is very important. This has to happen for each x in the domain of g. And similarly, g of fx or g of fx is going to be x for each x in the domain of f. So let me show you what's happening here. So this function I'm quite confident from the previous videos, especially on the ones that we had done the chain rule. You remember that this function f of gx is called the composite function. Yeah, so we're taking the composition of f and g, and if I combine these two conditions, then I can write it together as g of f of x is equal to x. So I can sum up these 2 points in this form, and again the composite function is going to give you x in both the cases, and this has to happen for each x in the domain of G. That's important. If such a condition is true, if you are able to check or if you're able to verify that this is true for each x in the domain, in that case you could easily say that the function f and g are inverse of each other. Another thing, talking about the notation, the way you're going to write about your f inverse, you are going to read it as f inverse, and when you write it, it will be an f with a -1 on the top. So this was the definition and the notation and the condition that you need to check in order to check for inverse function. This is quite an important part, and towards the progress of the video, we are going to be looking at some question in which we check for this condition. Okay, moving on, let me give you some important observations or facts about inverse functions. So there are 3 points that I've written here for you. Let me explain to you one by one. The first point is, if G is the inverse of F, then F is also the inverse of G. So this is like a reflective relationship. If one is the inverse of the other, then the converse is also going to be true. Okay, so if G is the inverse of F, then F is also inverse of G. It is one and the same thing. Second, the domain of F inverse is equal to the range of F, and the range of F inverse is equal to the domain of F. And this is quite a easy observation to make from the last slide, where we had taken the example of the 2 sets and we had seen that, how we are actually defining F inverse. So basically we were interchanging the domain and range, and from there we have our second observation. Let's come to the last observation. So a function need not have an inverse function, but if it does, the inverse function is unique. So this is also a very important observation. So in order to check whether a function is going to have an inverse or not, you are going to be just having in the slides to come a few examples of those kind of questions, and you will see that we check for one-to-one whether the given function is one-to-one or not. We check that condition, and then we check the condition the previous slide had given us in the definition about the composition, that f of g and g of f should be equal to x for each x in the domain. So all these conditions we are now going to be verifying, and remember, once a function is having an inverse, it is going to be a unique inverse. It cannot have more than one inverse. There is going to be just one special unique inverse for a given function. So now that you've got a good idea of what is the inverse of a function, how do we define, how you can write the inverse, what are the conditions you're going to check, let's go on a step further and try and find the inverse of a given function. Now, to find the inverse, there is a specific methodology that you need to follow, and for that I am giving you today 4 easy steps. Step 1, you have to replace fx with y. So whatever function is given to you, for example, I have taken here your fx as equal to x to the power 5 minus 4. So this function, step 1, you have to replace fx with y. So let's do that, and you are going to get, number 1, you have replaced your fx with y. So this becomes step 1. Step 2, interchange x and y. So what you're going to be doing, in place of x, you put y. In place of y, you put x. So you are just interchanging the 2 variables. That's your step 2 done. Step 3, you have to solve the equation for x in terms of y is possible. And in this case, in this question, if you see, it is more easy to express y in terms of x. So we are going to be doing that. So what I do here, I take this -4 on the other side, so it becomes positive. So we have y to the power 5 equal to x plus 4. Now, if I need my y from here, in terms of x. Then I'm going to be taking the fifth root of x plus 4, and that is exactly what is your third step. Okay, so we're done with third also. Last but not the least, to get your f inverse of x, you are going to replace finally your y with f inverse of x. So that gives you the final step, the final answer of your question. And yes, we have found the inverse of f of x equals to x to the power 5 minus 4, this function, and that has come out to be equal to the fifth root of x plus 4. So that completes the method, and I hope you have understood how you need to apply these 4 steps to solve any question based on inverse of one-to-one function. Okay, moving on, let's now apply whatever we have learned to this important example where we are going to find the inverse of the function. Okay, so I'll read the question for you along with the function which is given. So the function is, find the inverse function of fx equal to square root of 2x minus 3. So this is the given function. Now, before we proceed and apply the 4 steps that you've learned to find the inverse, let me give you the graph of this function. How does it look like? And for that, you could easily draw this graph on Desmos, and you will be able to see how the function is looking like. So just look at the graph of fx first of all. So I will take my pen and highlight here for you. So this is how the function, this black curve that you see is the graph of the function fx equal to square root of 2x minus 3. And one important condition, in fact, it's a property of inverse function that you are going to be learning again in the slides to come, is reflective property. Now, what is this property? Let me give you a quick overview. So this property says that when you have the graph of fx on the graph, you can easily draw the graph of f inverse by taking the reflection through the line y equal to x. So this dotted red line that you see is the graph or the straight line of y equal to x. And if you draw the graph of f inverse, that is x squared plus 3 by 2, that you will get towards the end of this question, you will also observe that this graph is again symmetric with respect to this line y equal to x. Yeah. So more things we are going to discuss in just a few minutes in the slides to come. So let's proceed with the solution. From the graph, you can easily see that f is going to be an increasing function in the entire domain. And that is quite evident from this black curve that you see for fx equal to square root of 2x minus 3, that this graph is starting from this point 3 by 2, and slowly as it moves on the right, the value of x is increasing, the function is going up and up, and it's increasing as well. So it's a function which is increasing over its entire domain. And to verify this, you can take the derivative. Definitely you know the power rule. This is equivalent to 2x minus 3 to the power 1 by 2. Go ahead, differentiate it, use your power rule. You all know about it. We've been using them in the previous videos. And then you will get your f prime of x as 1 over square root of 2x minus 3. Again, because it is square root, it is going to be positive throughout. And that tells me because the first derivative is positive on the entire domain of the function, therefore this graph of the function f is strictly monotonic and it is an increasing function. Therefore, it is going to be having an inverse. So we have checked that, okay, this function is increasing over its entire domain. In fact, it is a strictly monotonically increasing function. So definitely it will have an inverse. So now that we've checked the condition, let's proceed with the steps. Okay, so let's proceed with step 1. So here we are doing step 1 of the question, and that was to replace your f of x with y. So what we have done is, instead of f of x, I have written y here. Let's simplify, proceed, and write one variable in terms of other. So to remove the radical sign, to get rid of the square root, we are taking square of each side, and that gives us 2x minus 3 equal to y square. From here, you can take out the value of x by simplifying. So you take this negative 3 on the other side, becomes positive, y square plus 3, and then you divide by 2 to get your x. So that completes step 2. where we have written x in terms of y. So x in terms of y can be written as x equal to y square plus 3 by 2. So we've solved this equation for x. If you rearrange it a little bit more and then you apply your step 3, what does it say? Recall, step 3 says you interchange your x and y. So where there was x, let me now change the color. Yeah, so where there was x, you have replaced with y, and where there was y, you have replaced with x. So you have done your step 3 there, and now again finally to give the last step of the question to complete your solution, you are going to replace y with f inverse of x. So that completes step 4 and you have reached to your solution, which is f inverse of x equal to x square plus 3 by 2. Now that you've got your f inverse x, again you want to revisit the previous slide and check for the graph, look at the property, you can easily verify the same. Okay, so let's now proceed with our solution. So now we are going to check the last condition to just verify that we have got the correct answer, that our value of f inverse is right. So let me write again the functions for you. The two functions that we started with, fx, and the one that we got, f inverse of x. So these are the two functions we will be using to verify the result, which comes directly from the definition. So what we are going to verify, let me write that for you. So we'll verify that f of f inverse is equal to f inverse of f, and that is equal to x for all x in the domain. So what I'm going to be now doing is I will take the first part of the question. First I'm taking the left side. This is my left hand side. So I take f of f inverse x. That means I'm going to be plugging in f inverse x in the function fx. So this is my function fx, which is square root of 2x minus 3. But I'm trying to find here f of f inverse. So instead of x, I'm going to replace inside, I'm going to substitute, I'm going to plug in f inverse x. So let me do that. So I take this x square plus 3 by 2 and I put it inside this radical sign. So this is what I get. Let's simplify this, cancel 2, and that would leave us with square root of x square. Again, that has come to be equal to x for all positive values of x. So we have taken everything which was in the domain 0 to infinity. Yes, so one side is proved. We have got f of f inverse x as x. Let's take the right hand side now. That is f inverse of fx. And if we get the same thing, if we get this also equal to x, that means that we have reached to our correct inverse. So now I'm going to be taking f inverse x, that is x square plus 3 by 2 by definition, and instead of x inside I'm going to plug in f of x, that is square root of 2x minus 3. So let me replace that, and this square of 2x minus 3 with the radical sign plus 3 divided by 2. That's what I'm going to get. Let me simplify. I get rid of the radical sign. It goes because you have the square here, and then you cancel your common terms, and that leads to again x in this case. So both the sides, left and right, are giving you the same value x. That Okay, so that brings us to the end of today's session. Let me summarize what we have learned today. So in the lesson today, we first defined inverse function. We recalled that when a function g is said to be inverse of a function f, and the condition that we learned, and we had also checked that condition in the example in the last slide, was that f of g should be x for each x in the domain of g, and g of fx should also be equal to x for each x in the domain of f. So this is a very important definition. You will be using this in various questions where you have to find the inverse and then finally check whether you have got the correct inverse or not. Also, let me summarize the 4 steps we learned in the session today to find the inverse of a given function. Step 1, you replace f of x with y. Step 2, you interchange the two variables x and y. Step 3, you solve the equation for x in terms of y if possible. possible. If that is not possible, you interchange and solve the equation for y in terms of x. And finally, you replace your y with f inverse of x. That would lead you with the inverse of the given function. So I hope this session was useful for you. I would urge you to revise what we've covered today. This was a basic lesson, an introduction, and your understanding of inverse function. In the next session, we are going to be learning about how to differentiate such an inverse function. So see you in the next session. Bye, students, and don't forget to like, share, and subscribe to my channel, Mathematics Made Easy. Bye-bye.